Hey, what's up, guys? It's your boy, Mr. Willie, aka Big Willie Style, aka Uncle Doug. And I don't have the energy for this. So we're just going to do a normal math video. Today's video is sponsored by isosceles triangles. Did you know that every isosceles triangle is guaranteed to have two sides of exactly the same length? And that's not all. If you use promo code Euclidean at checkout, you also get a pair of congruent angles with your purchase absolutely free. That's isosceles triangles. If your triangle doesn't have congruent sides, it's not an isosceles triangle. Anyway, so here's a recap of what we learned this week. We started with the fact that congruent figures have exactly the same size and shape, and corresponding parts, so corresponding angles and corresponding sides, have the same relative position in two congruent figures. So for example, here's a pair of congruent angles, their corresponding angles, and another pair of corresponding angles. It's also important to note the exact position of a triangle or any figure doesn't determine whether or not it's congruent. These two triangles are still congruent even though one of them is a little bit rotated. The next thing we need to understand is how to read and write congruence statements. So in this figure it says that triangle PQR is congruent to triangle XYZ. The order matters here. So the first letter in each triangle tells us that, for example, angle P is congruent to angle X. We look at the next letter, that tells us that angle Q is congruent to angle Y. And similarly, angle R is congruent to angle Z. That also applies to the sides. So side PQ is congruent to side XY. Side QR is congruent to side YZ, and side PR is congruent to side XZ. Another theorem that we have is the third angles theorem. That tells us that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. And this is actually pretty simple to prove. So we're just going to imagine two triangles. We're going to call them A, B, C, and D, E, F. And we're going to say that we know that two pairs of angles are congruent. It doesn't really matter which two, but we're just going to say that A is congruent to D and angle B is congruent to angle E. Knowing that, we're going to set up a little algebra equation. We know that the angles of both triangles will add up to 180 degrees, which means that they equal each other. The sums equal each other. Then we can do some substitution. Since angle D is congruent to angle A, and angle E is congruent to angle B, we can just replace those with A and B. Then we can subtract the measure of angle A and the measure of angle B from both sides, and what we're left with is the measure of angle C equals the measure of angle F, which tells us that angle C is congruent to angle F. Triangle congruence has three properties that we care about. First of all, it's reflexive. So every triangle is congruent to itself. Congruence is a symmetric property, which means that if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. It's also transitive. That tells us that if our first triangle is congruent to a second triangle and the second one is congruent to a third, then the first one is congruent to the third one as well. We have some theorems we can use to prove triangle congruence. The first one we're going to talk about is side-side-side congruence. So if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Here we have three pairs of congruent sides. That's enough to tell us that the two triangles are congruent without having to look at any of the angles. If we only have two sides that are marked congruent, but the included angle is also marked congruent, then that is side-angle-side congruence. The included angle is the angle that touches both of the sides that we're talking about. So in this diagram, between side AB and side BC, the included angle is angle B. We also have angle-side-angle congruence. It's very similar to side-angle-side, except now instead of an included angle, we have an included side. It's important to note that in the name of this theorem, the word side is between the word angle and the word angle. The letter S is between the two A's. And the side that's marked congruent is between the two angles that are marked congruent. Our next theorem is angle-angle-side congruence. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So it has to be the same non-included side on both of them. In this case, it's the one that's touching the angle that I marked in green. And lastly, we have a special case if we have a right triangle. In that case, we can use hypotenuse-leg congruence. So if the hypotenuse and one leg is congruent to the hypotenuse and one leg of another triangle, then the two triangles are congruent. So just to recap, let's say you get to an exam and you can't remember what the congruence theorems are that you can use. Well, you can remember that most of them are 3 letters long and have S's and A's. So let's just write down every possible combination of those. You could have 3 sides. You could have 2 sides and 1 angle. So that could be SSA, SAS, or the funny word. You could have 1 side and 2 angles. So that could be AAS, ASA, or SAA. Or you could have 3 angles and no sides. Well, for reasons that we won't get into in this video, we can't use SSA or ASS. And those are actually going to be the same thing. We also can't use AAA. We need at least 1 set of congruent sides. We could have 2 triangles that have the same set of angles, but one of them could be much bigger than the other one. So we're going to take those off the board and add hypotenuse leg. And then really, I won't count you off for using SAA or for calling it that, but that's really the same thing as AAS. So we're going to take that one away as well. And these are the congruence theorems that you can use to prove that 2 triangles are congruent. Remember, if you like, comment, and subscribe, I might become an accidental YouTube sensation and make so much money from these videos that I could quit my job. So if you want to see me at the high school next year, maybe don't like, comment, or subscribe. Or do. I don't care. See you next time.